now, so we start our workshop today, all right? So for today, we'll focus on the Desmos calculator, right? And Desmos activity. So this is my website. Maybe I go back to the front page again to start the meeting. So this is my website, all right? And in the first page, you can see the tablet, all right, using tablet page. So click inside. And just like yesterday, you see the upper part, the major resource I recommend. Okay? We have gone through some materials in GeoGebra tube yesterday, all right? And for today, we'll try to explore the use of the Desmos tube. Actually, it's mainly about the Desmos activities. Okay? However, to begin with, I also like to try something first with the calculator, right? Because the calculator is the basic tool they provide. So we'll do something directly with the calculator to get you familiar with some of the basic tools and options there. Okay? And then later on, we'll move on to the activity. Activities means more than just the calculator, actually, all right? So you can try to explore or even work on this like the students, all right? So you can try to do some tasks together like the students. Later on, you can see that this is the links directly for students, all right? So actually, you can also see the link quite easily in my website later on. So there's one entry point for the students. And then the other one, just like yesterday, I have my notes to provide more details or more information about, particularly about some of the activities that I've already designed. Okay? So similar to yesterday, you better register there as a teacher, right? So that you can collect different materials and also build up your own later on. Okay. Are you ready? Right. Can you go to the calculator page? Okay. So this one. Okay. So this is the original starting point of the Desmos calculator, right? So you can see that it is already the first button there is allows you to start graphing. Right? So you can explore with the Desmos by doing some graphing activities. So it's primarily a graphing tool. You can even also see some project here. Right? So quite a lot of them are quite amazing because you don't know how students can produce quite complicated graphs based on these simple tools. There are also some examples, mathematics examples. So quite a lot for you to learn from. You can just click on this to see the materials inside. All right? And then very soon we'll go to the activities. Okay? After you get some basic experience or understandings of the decimal calculator. So, by the way, you can also see the simple for function and scientific calculator. I think sometimes these are also useful, even though they are not so sophisticated or powerful as the graphing tools, all right? But you can also make use of them for some other learning design later on. Okay, now so you can click on this one to start graphing. Is that okay? And I can sign in with my account. You can just start graphing without any account. It doesn't matter. Right? So you can open it to use it anytime you like. Understand? So the design is very similar to the GeoGebra yesterday. So you have the area for input, entering equations, coordinates, any other kind of expression within tables. And then you see the graph going on here on this side, or you can format the graph paper later on. Okay? So you can do it later or try it out. And so for the graphing, we can use the common method, right, of entering equations. Right? So you can do whatever you like. Right? For example, I just put down some simple equation. So you can see the simple graph. Right? And then you can click on this. Click anywhere, then you can see the coordinates on the line. Okay? Or find some specific points. Right? So this is similar to GeoGebra yesterday. Right? So you can use here like that. You can try very complicated expressions if you like. Right? Maybe I play with something like it and see what will happen. I don't know actually. Okay. So something quite interesting, right? Do you make something interesting? I don't know, just play with it randomly. Right? don't realize what this curve, how this curve comes out. Okay. All right, so you see how flexible it is. Okay. So you can type in any equations you like. You can also type in function. So remember, right? And so you can create a function. We work with parabola again, perhaps. So that will be a parabola, right? Can you see this? And then at the same time, you can also make use of this to create another function. F of x minus 3, where is it? Oh, okay. Yeah. Right, so you can see that you can make use of this symbol to create other functions as well. Or you can do trigonometric functions. Or even x squared. You see this one? Okay. So a lot of things can be done. Okay, now let's move on to work with the parabola again. Okay. Let's say I make this function. Okay, you can create your own parabola, okay? Anything you like. So remember, yesterday we have tried something within the parabola, okay? Adding geometric objects there, an equation, right? And then try some activities together. And here, we can also add a point. Right? So you can now you can experiment this way. Here, for example, if I press 1, 2, then it is just a point, right? I can enter it. And the graph, you can choose to format it this way. Let me see. It's not movable. Sorry, it is movable. So you can select the drag option here. Can you see that? Okay. Now do it again. So you press on this circle, right? Hold for a while, then you see the options coming out. Okay. So you can see how you can choose how to display it. Okay. And then you can open the drag option to make it draggable. Right? That means movable. So if I move it now, then the coordinates will be updated. Can you see this? Okay. And you can also open the label. Okay, switch on the label. Then you can see the label on the graph in the graph area. Right? The label here simply means a value. But you can also just name it by letter, like this. Can you see this? Or you can make it bigger if you like. So you can choose to do it any way you like. Understand? I think this part is easy, right? Okay. Now, if we want to put a point on the permanently on the graph, right? This is just temporary, okay? But if I want to put a permanent point on the graph so that I can move it and do other manipulation, then I have to label it this way. Maybe I create a new value, A, okay? And then f of A. Can you see this? Then they suggest to make a slider A, since you already introduced a new symbol. Okay? Then you just press enter, then they will create a live slider for you as well. Okay? So the slider here means that it allows you to change the values of A. Okay? Or you can directly drag the point on the screen. I'm now dragging it. Understand? I'm now dragging it in the graph paper. Right? Then the A will also be changed. Okay? It's dynamically. So the option here, even though they allow you to drag, okay, you can't drag it in 2 dimensions. In 2 dimensions, you can only drag it in 1 dimension. Actually, that means a long curve. Okay. Can you get it? Yes. Right. So I label this point A here. All right. I will point A, and you can see the value. Is that okay? Yes. Right. Now I go to create another point also on the graph. Right? You remember my example yesterday. I like the point to be certain distance away from A horizontally. So I create a new number B, which maybe A plus 4, or maybe smaller to make it easier. Okay. A plus 3. All right. Is it okay? So as a new variable is now created, A plus 3, okay? Yeah, we call it B, and now I can put another point directly, f of B. Okay? So you see the point B, somewhere on the graph, right? 4 units to the right of A. And I can also change the color to black to make it more consistent. Okay, can you see this? Yes. Can you do it? Yes. All right. So the next thing I like to do will be have a point C in the middle. All right, so I allow C equal to A plus B divided by 2. In fact, you can take away the bracket if you don't like it afterwards, all right? But when you press it, I think you need the bracket. So can you create a point based on C with x coordinates equal to C? So you can check it out, right? So C will be somewhere midway between A and B, horizontally 1 minute. Okay. I can also change the display. Maybe here on the right, I can make the projector mode. Is it better? Is it? You need not change the projector mode, right? But for me, because I'm projecting on the screen, right? So the projector mode will make it clear perhaps. And you can see that you can also adjust the setting, okay? The range of x and y, or the minor grid lines. Okay? And you can also make this adjustment here. Is it better now? Okay. Now remember, yesterday in algebra, I demonstrated how to make the triangle ABC. Okay? So in algebra, you can use the geometry tools. Right? Here, they will not provide directly the geometry tools. But I checked it yesterday. They now have a new tool called Polygon. You can find this out in the menu later on. Okay. So in this way, I can still make the polygon ABC. Sorry, what's wrong? I do not really name the point. So I may go back to the I actually have not defined the point A. Okay, I just give the label. Okay, but it's not defining as A. So maybe I define the point here. Okay, more properly give the name. Understand? So in this way, so I can make use of A, B, and C to create a polygon. This is a command. Okay, but this command is new one. So I just noticed this yesterday. Right? So that's why originally I assumed that you may not be able to make a geometric object so easily. But still, they may not provide too many tools for you to create geometric objects. So although it is already better with this tool. All right, now, but I don't play with the polygon today, okay? Because this is what we have done yesterday, right? So this time, I'd like to talk about the slope, okay? So let's write down the slope of AC. Can you calculate the slope of AC? All right? So you can do it this way. You can name the slope M sub 1 use the underscore. Do you know how to type the word underscore? In a keyboard, next to 0. Okay. Do you see underscore? Or you can open the, let me see, I think you can open the keyboard. Let me check. Do you have the underscore here? No such thing actually. So not really. But it's good to explore the keyboard. I can see it. Can you see the keyboard? Yes. Maybe I try this one. All right. Although you can also just use the underscore, okay? Underscore 1, and you will see M sub 1. So, okay, just name it as M1. So this is the first slope. Okay? Do you know where to get the keyboard? Yes. Right? So down here on the left, left bottom, you can see the keyboard if you need it. Okay, so M equals to, so the slope of AC. So remember how we define the point AC? Right, so the numerator will be f of c minus f of a, and then the whole thing divided by c minus a. I can remove the bracket, I think afterwards. Can you do the same for the slope BC? Slope BC. Do you get it? Now, do you see the button here on the left? You can choose to display the things in fractions. Similarly, for the above value, you can also choose to display them in fractions. Right? And also, maybe you can choose a better value. Then you can see more clearly this value. You get it? Okay. All right. So now the next thing I would like to explore is the difference between the slope. Okay. So what do you think would be the difference between the slope? So this shows you the difference between the slope. How do you think the difference will change when you move the point A? Can you get it? Can you get this value? So just calculate the difference. I can see with the 3. What happened when you change the point A? Can you see that? These two slopes change, right? But the difference does not change. You see that? Do you know this? Do you know this property?
No.
Okay, then you can go on to explore. Okay?
Yeah.
How come it works? So what happens if you change B? If it's not plus 3, maybe I make it plus 4. Okay? So what will happen? Let me try it again. Do you see I change it here?
Yeah.
Okay. So I can go on to try it now. What's the difference? It's 4. Right, you can zoom out to get more. Right, now I zoom out a bit, okay? So can you predict the difference if you continue to change the values of B? Okay, can you manipulate it this way? So now, at the same time, you can see we can do quite a lot of calculations. So these are the common calculations that you can do, right? And then you can try to display these expressions and study the relations based on the functions of the graph. So this is the way we like to use the graphing tool. It's not, of course, most of the time you may just simply input an equation and then plot the graph. I think that is the common usage, obviously, all right? Then you will make use of it in the classroom. But I try to introduce a little bit more directly, okay? That it's not just the graph, but things to do with the graph, okay? So how you can introduce more points or other slides, and then even suggest any other questions, right, for the student to explore, just like this one. It can be interesting to find out why the difference does not change, right? And then how does it depend on the function? If we change the function, what happens? If we change the quadratic function, right? If we change the coefficients, what would you expect to be the result? So you can think about it. So this is the way that you can explore. And any question from you? Or any suggestion from you? Do you have any suggestion? Now, so as I mentioned, it's not so easy to add other geometric elements in the graph, right? But since we have a new tool, you can still try. For example, if you want to join AC, I tried it yesterday. You can just press AC. Right? So, of course, it's just a trick, okay? Instead of polygon, it just gives you a line. Okay? So you can display the line in this way. Okay? Or I think another option you can also try would be simply to plot a line through AC. Can you write down the equations AC? Right? Can you remember the coordinates? Okay. So the straight line through AC, okay, will be equals to because we already calculated the slope. So I just make use of the slope. Does it make sense? So that is the line through AC. Okay? So that is, and then I can also add the line through B, maybe. Okay? So it's quite handy, I think, right? And then you can also practice the use of the expressions. Because if you want to add something or you can control the graph, then you may have to make use of this kind of symbols. I'll try to think about it, how it can work. Right? So you can embed all these in the activity. That means encourage the student to make use of the algebraic expressions, right? Try to think about how they work. Right? So this is the graph. Right? So if you change the A again, then you can see the graph change, right? Now, provided that the graphic is not too messy, right? I don't know. Right? Just try to get. Of course, you can also hide the line if you like. On using this button, right? You can switch it on and off, or adjust the appearance. So maybe you make it a dotted line. I don't know if you think that this is better. Yes. Right? Or just dashed lines like this. Or maybe make them both the same color. Maybe easy. Let's turn off the projection mode for a moment. Would it be better?
Yeah.
I don't know whether I can make it stick or not. Oh, I think that's what I can do. Right, can you follow? Is it okay? Yeah. Now, so you can see that the input area on the left, right, becomes quite easily filled, right? So it's very crowded. So sometimes I may like to have some folder to hold some of the objects, right? So you can see this option here. So once you have now input all these are expressions, you can just type notes, right, in each field. You can write questions, maybe instructions. If you make a file, and then share it with your student. Maybe you can type some instructions there as well, right? You can add a table. You can try it later. You can add a table. You can add a folder, or even image. Image here simply means an image on the graph, right? Sometimes maybe you can see some examples later anyway. Okay, so you can import an image and then you can graph on it, right? You will still make a graph on top of the image. Okay, now I create a folder. So a folder here, right? Just for holding the things. Maybe I just call it I, right? So I can put something inside. For example, I don't need to always refer to the line. So I can just put it inside. It's already inside. Can you see this part? Because when I move it, you can see this line, okay? It shows that it is put inside the folder. Okay? So I can hide it. Just to make the layout better, okay? So I can move it out. And then maybe the A, I don't really need it now. I can put it inside. Okay, can you see this? And then what else? I can put it inside. Perhaps that's all. Okay? So it may keep the screen, okay, more tidy. Can you do it? Is it okay?
Yeah.
Right, so you can take away if you want. If you finish typing, you can put aside the input field for the time being. Then you can just concentrate on the graph now, right? So refer to the graph. So it shows that according to the values, you see the difference of the slope does not change, provided that A and B are the same horizontal units apart, right? Horizontal distance apart. Okay, the final question: what happens if C is not the midpoint, but just anywhere between A and B? So I still have this point CFC below, right? So now I just remove these expressions. So I can just type any number I like. It can be maybe 2, somewhere here, okay? And I can make it a slider, or for maybe from negative 10 to 10 in the step of 0.1, okay? Do you see what happened? So the C is any point, okay? Even outside, okay, or beyond A and B, okay? So what happened to the slope? Can you see it here? Still the same. Yeah. Even if I move it outside, you notice that? Even if I move it away from A and B, we still have the same difference actually. Yeah. So actually this time, it's not necessary to be the midpoint at all, right? It's different from the question yesterday. Alright, so this is more or less I'd like to share with you here. So you can go on to figure it out, right? Why it works this way, right? Or later on, if you're interested, you can also think about how to discuss with the student in the lab, right? How to turn it into something you can kind of teach the students. Now, if I finish this, then I can save it. I can save it here, right? And keep a title. Actually, I've done it myself yesterday. This is my version I had tried yesterday on my own, and I've saved this one. Right? I will share with you the links in the Moodle or through email, right, to share with you later. Okay? So you can see my file directly. And then, so let me see. So once you save the file, then you can share it. You can have a copy of the link. Okay? And then give this page right, to others. Right? You can share it. Similar to last time, you can also change the language. Okay? There's also quite a lot of options for you to turn to explore and study. Okay? All right. So any questions about this example? Any questions? No? Then I just leave it. All right. And just quickly show you the example yesterday. I mean, when I usually in GeoGebra. All right, so this is example I've done in GeoGebra yesterday. That is the triangle, right? And C is midway between A and B. As I mentioned, I can now draw the triangle So this problem can also be studied in the same way. Okay? And then I give the hints here. I ask, is it easy to find the area? And the hints are actually the folder, it's the folder. Okay? So I can show you, you can still click on the hidden part. Right? So at the point D, can you understand the point D? This is the point D, I add the point D here. And I add what we call polygon, actually it's just a segment here. Okay? So this can also be shown hidden. Okay? And then H, I also calculate the H. That means this difference. Okay? So I calculate H, and then you can see this one. So this is what I have done yesterday, and then put it in this folder. Okay? So the question can still be studied here at the same time. I don't repeat it. I'll send you the file later. Okay, so you can study. But I think that the structure is more or less the same. Right? You can also see my instructions. Right? Some part of text. So I just type the instructions or questions inside. So any question about the graphing tools? Is it easy to use the graphing tool?
Similar to the GeoGebra.
I think the basic features are quite similar.
Yeah.
Yeah. Only the later part, what I do in the later part, I do quite different. As I mentioned yesterday, I think one of the major differences is that you won't do too much on geometric objects in this grade. Okay? Although you can still do something useful. Just so happen useful in this example, right? But compared with GeoGebra, you don't have so many different geometric tools to use directly. Mostly we rely on equations. You can still do a lot of things with algebra actually. Okay? If you know how to type perpendicular bisectors, angle bisector, okay? You can check all the formula if you like. Okay? You can still do it, but analytically, it's not graphically using the mouse. Okay? But the main point is not doing that, of course, here in the Desmos. Right? They try to make the layout handy, and that means the student they also find it easy. Right? If you don't have too many tools at the same time, and if they're working on some standard kind of task or bookwork, then it will be useful. It will be useful, right? More convenient for that. Okay, now, but I can show you some examples that we discussed yesterday as well. The integral. Okay, so we can do integral. Can you see this? So I input a function f, and then g here is the integral. This is what I say I can't input yesterday. I enjoyed it, right? However, at the same time, I cannot directly show the trace of the point, but I use the table instead. Can you see the table here? Right? The table, I can show you how to input this. So the point g. So once you have a function, then you can go on. You can use the keyboard. Under functions, miscellaneous, you can see the integral sign. Okay, so I start with from 0 to x, and f of t dt. So it's very similar to your usual input. Can you see this? Right? Choose this one. Right? So I like this form. It's very good. Right? It's very nice. Right? Very similar to textbook thinking. And in that way, you can directly see the function, the integral function. Can you get it? Can you type it? But I've checked that. It seems I can't directly show the integral and the area in the graph. Right? And although I can do it in GeoGebra, right? So that's why we can't do both at the same time. Okay. But you can ask questions like this. If you turn it to, let's say, I input a constant, what will happen if I just move it up and down, what will happen? Okay, you see? To the function g. Alright. You get it? Now, I can also use a table, okay? So I can add the table there. This is a table. Right. Now a table here simply means some collection of points. It can be, right? You can rename this label if you don't want it to be x1, y1, or the simplest one will be just x and y. Right? So you can start input any coordinates. I just randomly put down something, understand? And then I can turn it into other color. I press it and hold, then it will be turned into other color. Okay? And I can also join it with lines. You can explore this option. Okay? Or join them with curve. And I think it's curve. All right? Or just line, I'm not too sure. Or just point. Alright, so can you understand? Right? You can use the table to explain. Okay, or you can directly turn the table into a tables of the function. Can you see what I put now? Right? Or you can change any values you like. Maybe you can start with 0, and then this is 1, and this is 2. Okay? Or maybe 0.5. Okay? Or use the fractions. Let me try. I think I can use the fraction as well. Okay, so you understand? You can add a column. I think if I oh yes, if I go to the first row and enter, then I will insert one more row. Right? Now this is very handy because it allows you to discuss with the student anytime, anywhere you like. You don't have to. For example, you don't have to worry so much about the order of the number. If you want to insert the number in between, then you can ask, right? Or you let them guess what will be the values, right? For some x values in between. So, okay? You get it? Right. Now let's change to g. Okay, now I change to g. That means the integral. Can you see this? That is the integral now. I can move I think the scale is not too good. Now, do you see what I'm doing? I'm holding the shift key, and then drag only the y-axis to make the scale better, because I want it to be in a better proportion, 1 to 1. Okay, I think that's enough. Similarly, you can also hold your shift key and then drag along the y-axis, right, to change the scale. Now let's turn off the function. Okay, so I only see 3 values. So I can enlarge this part. So this is 1 value, 2 value, 3 values. Can you see this? Yeah. Yes, can you see 3 value? Yeah. Now let me ask you a question. If I add one more value, 1.5, what would you predict this number? Should it be greater than 0.5x3 or smaller than that? What's your prediction?
Smaller. Because the derivative is negative. So it's increasing.
Yeah. So this can be a question for the class.
Yeah.
Do you see that? All right. So I can ask, what would be the value? Right? That's one more here. That is the reason why I say now I can add one more row. So what happened to this? Something's wrong here. Well, why disappear? Never mind. I don't know what's wrong. Yeah, it goes down a little bit. Okay. So you can check the graph here, and then try to discuss. So you can generate questions like this. Okay. So that's the way I can use the graphing tool. It's not simply directly showing the answer. Okay. But you can think about along this line. If you have this tool to display, okay, this element or that element, so what kind of question can you raise on spot, right? And discuss with the student. And based on what will be shown. So you can check carefully. Now, even though as a whole, you will find that all these tools are quite simple and intuitive, right? You're entering things and then hiding things, or sometimes showing things, right? But how do we combine it together, right? To present some question or some task for students, working together. So we can look at the graph again. So that's the graph. Okay? All right, so maybe that's all for, I guess that's more or less I like to try. Okay, with the basic graphing tool. By the way, you can also do derivative. Okay, maybe just show quickly. If I do, if I add a point A, F A, then you have a point A here. You see this? Can you see my point?
Yes.
Okay. And now I can add a tangent. So how do you put the tangent there? The slope is f prime a at the point A. It's minus A. Similar to the previous one, I typed the equation on screen now. Any more? To finish it, that's the tangent. See the tangent? And that prime A is the derivative, right? So you can use the prime notation to calculate the derivatives. So actually, I can turn the table. So similarly, I can turn the table into f of x together with f prime x. But the display is a bit strange. Now you cannot really display the value here. I don't know why the display looks a bit odd here. It's overlapping, but can you see that comics? Okay. So you can now talk about the derivative in the same table. And sometimes we talk about transformational functions. Can you see that? Right? So I'm transforming the function and talk about it. If I create tables again, I think a bit odd. I don't know why tables like this. So this is x. This is f of x. And this is f of x plus 2 plus still a bit strange here. 0, 1, 2, and then I just press return. Can you see this? If I start with 0.5 and then return, you see what's going on? I think this one's better now. The display is now is go back to normal. You still see some relations, right? 4.125. Can you see that 4.125? And then this is 10, and that is 10. So we can find out the relationship this way. Okay, maybe you try a little bit on your own, then we'll move on to talk about the activities, the Desmos activity. You can use the platform. I think the I have to try that. I'm not sure. I guess it's not allowed. Continue to explore.
This is a very good way to teach transformation functions.
Oh yeah, you can think about simple activity. Okay, can we move on? Are you ready? Can we move on now? Okay. Now, so you see that you can do the basic graphing. Okay. Then, based on this, we try to create some activity. So I leave this page. Okay. And so in my page, you can see the decimal graphing. Decimal activities. Right. Or you can also open my notes. Maybe I open my notes here. This is my Evernote file. Okay. So this is the activity homepage. So notice that the page is called teachers.desmos.com. Okay. And so it will provide a platform for the Desmos activities. So similarly, you have the student page. I have also some collection, right, of activity. So you can see this bookmark, right, for my activities. Some of them are created by me. Some of them are just gathered from other users. So I do not put down the login here. It's okay, maybe I can show you the login later. Okay, so you can go to the Teachers Desmos activity page. This is the one. Right, so this is different from the previous one. Right? So it's still Desmos, but it is for the teachers' activities. And if you scroll down, you can see still the calculator homepage. Okay. Or if I go back to the calculator homepage, then you can see this one. So the earlier front page is like this. Actually, you can also find Teachers Desmos and classroom activity here. Right? It is the same link actually. Okay. Now, so what are the Desmos activities? Now, once again, you better log in with the teacher account. So this is my teacher account. Okay. I can share with you this teacher's account later. Actually, this is an additional teacher's account I created. I have another one, right? But this one I deliberately created for sharing, okay? Because I also like you to try my activity inside like a teacher, right? That's why I created this one and then just let everyone enter with my password. There's nothing else, right? Apart from this account and the password. But you can also see all my files there, and then later on you can try it out as a teacher to know how to edit or try to manipulate the students' response. Because now once you run the activity, it's not simply a set of questions. It's more about collecting students' responses and how to work on students' responses. Okay? And so you can visit it later, but not now because you can't access all of you can't access at the same time. Okay? I think you can do it later. I hope I can show you the account later on. This is my account name. Okay? Can you see this? And that's 2018 hongkong@gmail.com. Okay? And then password is Euler 2718. Euler EULER, right? 2718. Okay? So you can use the password. Okay?
Sir?
Yes?
So for our personal accounts, do we have to like buy a subscription to use it?
No, it's free.
Okay.
Yeah.
Okay.
So you should create your own teacher's account. All right? And then you come to my account only for exploring some of the material. Right? You try not to add your own materials here. Okay? You should have your own account, and then you can copy my activity into your account. Understand? Okay? But you're not doing directly anything inside my account. All right. So let me see. Okay, now most of these activities are created by the Desmos team. Can you see this label?
Yeah.
This is the Desmos team. Okay, so the authors as a team creates a lot of activities. Okay, but many of them cannot be easily made by ordinary teachers, right? Because they involve some programming, among themselves. Okay, but you can try to learn from the design. Right? And then you can use directly the activity. Okay? And for example, this one, I think this one is the recent one. Okay? If you click on this, then you can see this page. It's allowed you to create a student page. Now these are the slides. Right? So when you open activity, the student will go through all these slides and answer the question inside. Okay? And so you can have a preview. This is the student preview. Right? So in the student preview, you can see that these are the questions. Put the numbers in order from least to greatest. That means you are allowed to move around and then answer the question. Right? So once you finish, then you click on the next page. Okay? Then you will, as a student, you will leave your answer here. Understand? And now these are the tips. Sample responses. Right? So these are provided for teachers, not for students. Right? So that is called teachers move or teachers note. Okay? And you can close it. That means what the students see will be this area. Right? These are just for teachers' notes. And the next question, as I mentioned, there's a number of slides. Do you see that? Maybe I enlarge it. So these are a number of slides. So if you click on any one, you can enlarge it to see a bit, or even fill up the whole screen. Okay. So put the numbers in order again. So it is another question. I think you can try it out. And then this is the question: which list was easier to sort? Okay, so you can choose either this one or this one, and then enter your explain your thinking. Alright, so student will answer by inputting here. Okay? And then is a table. I think it's further question, right? Now, so when you design some activity, you can also create this kind of table, enter your question, allow the student to give an answer, okay? And then you can check the answers later. So these are images, right? You can import image, okay? Like this, and then ask a question. Or enter, now this is a table for you to enter numbers. Okay? So as an answer. So you can enter an answer there, and then check. So what is it asking? Enter this number below, then press check mark. What's the answer? What did they ask? Put planetary orbits by entering the distance from Sun using scientific notation. So Mercury's distance from Sun is 3.6 times 10 to the power 7. So scientific notation, that means 3.6 times 10 to the power 7. And check my work. Okay, correct. Now usually you can import image, right, when you create your own activity, but you cannot provide this kind of animation. Right? I think that they need some other programming procedures, right, to create some more complicated interaction. Okay? But you can have a look what they are now generating or using. Okay? But you can still do a lot. I'll show you. You can still make a lot of different kind of questions there. Okay, you continue, right? So these are the questions that you can continue and then check your answer. And this is another question, another scenario, all right, for you to input some answer. Okay, that's all I think for this set, all right? Now, so many of these activities you can find in the home page. So many of these are created by the Desmos teams, right? And they may provide different features, different ways of allowing students to input and interact with the screen, okay? And some of them cannot be so easily made by ordinary teachers. Okay? But now I'm showing you what you can do as a teacher, right? And to create some of your own activities. So these examples are done by me, okay? I go on to this collection. So if you enter using my account, then you can see this collection and custom page. Okay? You can check it later. Okay? So these are some of them are created by me. Now you can see this label, created by you, that means I made it. Okay? But some are edited by me, that means I copy from someone else and then try to edit. Okay? So, now this one is also created by Desmos, which I can still edit. Right? But some cannot be so easily edited. So you can have a look. So these are history. What I've done with some students, I even tried one circle geometry task with you in the previous lesson. Remember?
Yeah.
Okay. So I can go back to this this class. This is one example of activity that I've tried with you. Okay. And so these are the questions. So I can always go back to the students' work and then to look at the result again. Okay. Okay, now let's do something together so that you know better what does it mean. Okay. Let's try this one, equation in two variables. Okay. So that is the slides I created. Can you see this? These are the slides I created. And then you can check the student review again. So this is the task I create for junior secondary students. Okay. So you can enter it and try. Now when you start an activity with a student, you create a class code. This one, I create a class code. So once the class is created, then I generate a class, right, with this code. Okay? And then I will allow you to enter to work on this. Now, when I open it, you can enter it, just put in any name you like, okay? You don't have to give, you don't have to register there, okay? You can end it anytime you like with your own name, okay? and you decide whether you use your real name or not, right? Because your work will be left here in my account, okay? So it's up to you whether you want to create a new name. It doesn't matter, okay? You can design, understand? You just put down the name there and then you enter as a student, that's fine, okay? In the real classroom situation, you can ask the student to enter with a Google account, so that the work can be traced later on. I mean, from one activity to another, right? They can see all the work from different activities, right? But if you are just collecting work on only a single activity, or you don't plan to trace them, then they can enter whatever form they like, okay, or using their own name, okay, and without any accounts here. Understand? All right. So if you're ready, then now I enter it. Okay, open. So that is the first screen. You can see the website student.desmos.com. You can use the browser and enter that site, and then type in this code. This is the code. Right? All right. So this is the way that you can do it inside the classroom, together with the students.
Is there a limitation for students, number of students?
I don't know. I haven't checked, but I think not particular concern, because I also try with quite a large number, quite a large group. But I haven't checked. I don't know exactly whether there's any limit or not. Okay, is that okay? Yeah. I don't think there's any problem, because I heard some teachers do it regularly with their classes, the real classes in Hong Kong. It can be up to the size of 30 or 40. So I don't hear any particular problem here. All right, okay? Now, so this is the way that you can now do the task together in the classroom. But there's another option here. You can copy this link. You already created a class. So you can now copy this link and then send it to your student and ask them to do it at home before the lesson. Right? So you don't have to actually do it inside the classroom. Right? In fact, I prefer this way, better than actually using the class time. It's not necessary always using the class time to do the task. Okay? So you can just provide the link. As far as you're opening the class in your website, then you can just provide the link that they can enter and do it anytime they like. All right? Okay, so when you go inside, then you can see this? Now these are your names, right? So enter here. And then these are the pages that you will see. This is just an introduction page, okay? Starting from the next page, you can do things, right? You can answer questions. The question is, now this is very similar to the graphic window you see, right? I just make use of the graphic window, all right? And then input some question here. So I make a very simple one. I create a table. You remember how to create a table? You just press the number there, you have the table. Right? And then I ask you, can you guess the relation between x and y in this table? And then enter more numbers there. Right? So it is very easy for you to just try it out together. Right? And for a student, you can imagine what I like them to do actually here. I mean for junior secondary levels. Okay? So you can imagine what I like them to try, and then try to explore together on the ground. So you remember, this is the previous graphing tool. Right? I put it into the activity environment, right? So that I can put it into individual slides, and then I can enter the question, and then I can collect the work. Most important is that I can show all the work together, and also collect the work and think about the response, or try to think about what to continue and what to follow up with these activities. So have you tried? You can do it now, maybe. Just go through the slides, okay? Okay, are you ready? Okay, so let's look at the screen here together, right? As a teacher, right? See what's going on. Or maybe you can still work as a student, right? But I just showed you as a teacher, I can now access all the material, right? And I can also choose to display your work together and then discuss with you as well. Okay? So there are a number of things that you can do. First of all, you can go to the summary. Okay, so you can see that. Now this will give you the progress, right? All the names are here. And then, so I can see the first one is not a slide of any questions, okay? And the second one, you can see most of you have already done something. And the third one, not everyone have done all things, right? And fourth and fifth and so on, so you can see the progress, right? Or even knowing the student which page they're working on. You understand? Right? Now, on the left top, you can see this button. This anonymize, right? Anonymize means that I can now randomly generate a false name. Wow. Okay? So in this case, actually I can start with anonymizing before I show you, so you don't know exactly which students are doing which work. Okay? So it will be, I think it's a tool for facilitating discussion in class. Understand? Mm-hmm. So you can still safely show the students' work without displaying their identity. Mm-hmm. Right? But you can cancel this later on and then check the names afterwards, right? So you still have the data, right? But you don't have to show it now in class. Now, if you really want to stop the activity, you can pause it so that they can no longer work, and then everyone have to look at the screen together, right? Or simply pacing, that means just focus on one screen, right? Or two of the slide, and then just discuss some of the work together, right? I can show you this one later. Do you understand the interface? Yes. So I can go to task 2 now. Task 2, now these are the graph that you have made. Do you see that? Okay. So I can enter any one of this, and then I can check the answers together. Okay. So you continue to create some points following the same relation. Okay. And at the same time, you can also see what happened to the points. Now, provided the student may not truly, okay, familiar with that, then this can be something for discussion. Do you realize it? Okay? So you can ask them, what happened to all the points? Okay? I can still manipulate the graph. Now, this is the student's graph, but I'm manipulating the graph. Okay? And then try to ask, okay, what happened to the points? I will close it, then these are the other points. Do you notice that? Okay? Or I can ask the student, what do you notice about all your graphs? Now, but you are inputting different points, right? But I can still ask the question, right? You can see roughly what happened to all the graphs, right? Now, I may not assume that you draw the line, but at least you can see the points. Do you understand? Right? It's okay, of course. It depends whether the student know the equations or not. But even without knowing the equation, we can already talk about what happened to the point, right? Are they the same? Now, these are the things for discussion. It's not just for checking, okay? It's not just for correcting the answer. And if I put the overlay, that means all the graphs are now in one, yes, in one page. Yeah. Of course, you may not easily see the difference, okay? But now all your points are put together in one graph paper. This is what I mean overlay. Right, understand? All these are pushed together. Right? So what do you notice about the points?
Are on the same line?
They're on the same line, all right? But why is it one point not on this line? Why?
Someone made a mistake.
Huh? Someone made a mistake. Who made a mistake?
Yeah.
Who made this mistake? Okay, is it correct?
No.
So is it really a mistake? Sorry. Can you see it?
Yes.
Right, so you can check it, right? What's wrong? What should be the relation?
Should be 6 and 12.
Huh?
6 and 12.
6 and 12, right? So what should be the relation between x and y?
Y is 2x.
Yes, y is twice x or y is 2 times of x, okay? So you can ask the student to tell. So I'm not talking about whether so what's the right answer or what is wrong, but I allow the student to talk. Alright? I will ask them, okay, if this is wrong, then what's wrong? How will you describe the relation? Right? Then what should it be? And so this is part of the discussion. So it's part of the activity inside the class. You see that? Okay? So that's why it can be very useful, depending on the student response, of course. Okay? So I go back to the one, this is the one who made a mistake. Now I'm opening individual students' page. You notice that? That is the wrong point. Okay? And why is wrong? Now we can go to invite the student. Can you change it?
Yes.
What should it be? 12, okay? Because we assume that y is twice the values of x, okay? Is it correct now?
Yes.
Okay, so this is the 0.612, right? So I'm using the student's page, you see that? Now, but I'm not really changing that particular student's work. I'm just manipulating instantly the screen, right, on the screen. So the original student work is still there without being directly changed by me, okay? So I can still close the screen and then go back to this work again. Right? Understand? But I can make use of any of the students' work and then put forward to discuss with the class. Is it clear?
Yeah.
All right? So do you know how to use it? All right?
Yeah.
All right? So do you know who made the mistake?
No.
Any idea?
You?
How do you know this me? Now that's the interesting part. Because I'm joining you, actually I also entered it as a student in my iPad. Okay? And that's why I can also secretly, okay, and this together and go to the class. Right? Just in case you don't see any mistake from the student. And you can introduce some on your own. Alright, and discuss with the class. You see that? Right? So without disclosing the student's identity, they won't know what we're talking about. Right? So that is the way you can try it. It's very flexible. You also can use another device and then enter it and work and then work together with the student. Okay? Right. Anything else you would like to try? Now you can continue to use the graphing window. So if you really want to conclude y equals 2x, okay, then you can type the equation here, right? Or invite the student to suggest, right? So what's the equation? And then you can do whatever you like, okay? Or you can just enter another point, 3, 6, right? Or invite the student to suggest if I have the x coordinate 2/3, what should be the y coordinate? Because usually the student may not enter points like this, right? So you can invite them to try. That means you can continue to use the, so because I want this point to be a little bit special, to display it on the screen. So something like that. So this is the point. So anyway, you can continue to use the graphing window for adding other tools or any other materials and continue with the discussion. You understand? Okay. You can also see this. Can you see this camera?
Yes.
Right. So you can click on this to record this result. This is a capture. Because during the process of checking the student result, you may want to keep track of some of the work. All right? So you can also enter, for example, I find that this seems to produce a lot of points. Right? So maybe I'm interested in this graph, right? There's a lot of points close together, then I capture it. So when you go to the snapshots, then you can see these are the two parts I have already stored in the account here. It can be used for later, right? Because later on you can, because when you're working with the real class, there can be quite a large number of students response. So you may need some way to organize, right, the students' work, so that you can talk about it later. Right, so given the students' will, and then this is the next task. Right? Similarly, I can work in the same way. Okay, so I can open it and then check this. Right? And then now you will find that this is starting with the same points 2, 4, but I now shift to another relation. Right? So actually, I deliberately designed this way to invite the student to talk about different relations between the point x and y, the coordinates x and y. Right? Even though starting from the same pairs of numbers 2 and 4. Okay? And that need not be done in any order. Right? You can enter any point you like. Okay? So we understand the features. So overlay is something like this again. Right? You still see a straight line, but you can't compare this one to the previous one directly. Right? You can only shift back and forth to see what's the difference. So that is, this line is different from the other one, right? So you can discuss or ask the student to describe how it is different from the other one. And so you can also, maybe you can just capture quickly some points, some graph, right? So for further discussion. So, and similarly, I think you have already finished this one, right? If you pick up anything interesting, you can ask the student to talk about that. And then this one is also another relation. Okay, I think this one is different. Am I right? So what are the points I have created? I created these 2 points only. Am I right?
Yes.
You created 4 points.
Oh, 4 points. Yeah.
Yes.
But someone just added an equation without adding points. Right? But you can also ask, does it fit this curve? No, okay, you can see the difference. Okay? Okay. So you can now go back to talk about how the other I can create a curve, right? Fitting all the, so these are fitting the line, okay? And then, so you can put them together. Yes, you can still. This time you see a line. Okay? So it's not the same line. And how about the 7th? So you can see, this one is interesting. You have a lot of different equations. I can capture it. Okay. So all of these pass through the same point, 2 and 4. Okay? But they are different equations. So this one is also interesting, right? See this one? It's not difficult to create an equation actually.
Yeah.
Right? You just play with the number anytime, any way you like, then you can have different curve. Right? So you see how to work with this. Right? So you can just make use of the table and the graph window, and you can start with this kind of question, and then collect the students' responses. How about the students' will? I don't remember what it's like. I think these are just individual students. Okay, so these are just individual students. Screen 7 of 7. How can I move on? Let me see. Is it a particular student? No. This is the. I remember. This is the original screen before the students were. Right?
Yeah.
So it's not a particular student. Right? I just find this label a bit confusing. Right? It's not about a particular. It is original blank student page. Okay. So you can. That means you can get back to the original question. Okay. So look at it. What's the original question? Right now, get back to the snapshot. So I provide some. I get some examples like here, right? So I can ask. So, what's the difference between these two? Okay. So this is from the first set, and then this is the first set. All right. I can put together. All right. That means you can prepare. Right? So you can put together different results that you want to talk about it. Just generate other collection, and then get ready to present. Right? And particularly if you review your students' work before the lesson, then you can prepare quite a lot. Right? That's why I say it's better to try something, ask them to do the things before the lesson, and then you can plan well ahead, right? What to do with the students' work. Okay? Although within the lesson, you can still open up one or two of the slides and then let them continue. Right? That is my suggestions. Understand? Is it clear?
Yes.
All right. Now go to the pacing. What does it mean? When you do the pacing, now I can just hold to the first one of the screen, right? Or two. Maybe two. Maybe 1 and 2, okay? Or just 2. So anyway, I think you can see only screen 2 and 3, am I right?
Yes.
Right? Now I restrict to these two screens only. Right? Now how do we use it? So you can imagine that maybe you can control the pace. You can ask them only work on the first two before we continue to discuss, or you want to discuss this result before you move on. Okay? So you can ask them to concentrate on these two, or you open these two for the students' pre-lesson work. Right? So you keep these 2 pages, then the student can only access these 2 during the pre-lesson work, and during the lesson then you can open up the rest. Or the other way around, during the lesson you shift to the other slides, okay? And then go on to talk about something else. Okay? So you can work on this way. If you stop it, then you go back. Right? So this is the pacing. You can type the pace on this one. So you can see that we restrict to screen 4. All right? So that is how it works. And you can do more than one. But they have to be consecutive, I think. I think they have to be consecutive slides. Right? It's not that so flexible. You can't just say 2 and 5. It's more like you can't do it like this. Okay? Stop. Let me try to check it. No, it has to be continuous, you see.
When you click for again.
Huh? I can't choose 2 separate slides. Okay? They have to be continuous. They have to be consecutive. Okay, and or you can simply pause. If you click pause, then everything stop. Okay? What happened to your screen?
Activity pause.
Oh yeah, activity pause. So you can't even do anything on the screen, right? You can only see my screen. But I can still work. Now My screen still works. Okay? But I stop all your work. Okay? I think that's more or less, because this activity is relatively simple. I just asked you to draw graph, right? So there's not too much to demonstrate now, but I'll show you the basic layout of the teachers, okay? So you know what the teachers can do inside the classroom, right? So that is a platform particularly designed for this kind of collaborative and interactive work inside the classroom, or maybe outside the classroom as well, right? And then try to make use of the students' response for the design of the teaching. Okay? So, do you have any questions? So you can now I go back to my page. Okay. So if I go to my custom page, I can see this equation in two variables. Okay? Equation in two variables. And you can see this class, understand? So if you enter with my account, okay, then you can go home and then try to enter it with my account, okay? And then you can see this page. And then you can open this class which you have just done, okay, to review the students' work, or try a little bit how to organize or manage the students' work as a teacher. And this is the activities page. Right, do you understand? Mm-hmm. And then, now when you go into this site, you cannot copy my file directly. So you can see the options of active or sharing activity. Okay? When you share the activity, or you can just copy this link. Okay? Now this is a link for teachers, not for students. Okay? So you can copy this activity. And then share with teachers. Or you copy it and then you use another browser to use your own account and then open it again with your own account. Then you can keep that in your own account, understand? Yeah. It's a bit clumsy here. You have to open two browsers anyway, right? Or maybe use two browsers and then log in with different names and then you just copy it into there. Okay? But for students, if you want them to do before the class, you should copy this link. Can you see the difference? Right? Yes. So this link is for students. Now, so this is one class, but I can create another class based on the same activity because I may work with different students, right? So you can speak based on the same set of slides. You can create another class. So, any question from you so far? Do you have any questions?
So these activities are all made for use Desmos?
Yes, using a Desmos. Now I can show you how to, maybe I can create, I go home. So you have to go to custom page, and then you can see these options of new activity. On the right, can you see this?
Yes.
Then you can click on this, and then you can create a new activity. Okay. Then you can create a name. For example, I want to do a student test here. Okay. So that is the starting point. Okay. So when you create an activity, then you can now these are the slides. On this side, you can see a number of slides. Right? And on this slide, you can decide what to put in the slide. Right? The basic thing, you can see graph. Right? The graph is the first thing I think you can imagine. Right? You can easily put here and then start asking questions. Right? Later on, you can explore the other things. Right? Because you can put on also other elements in the slide to create the questions. Now let's do the simpler things. So if you do graphing, okay, then this is exactly the same window that you see. Right? So it's quite intuitive. Okay? So for example, I can enter the equation here. Can you see this? Okay. Now I can ask what. Sorry, I have to put down. Put that note. What is the equation this graph. So maybe you can ask the student to enter the equation here. Do you know what I'm doing? Yeah. Now, but why I asked you this question? I already showed you the equation.
This equation is only for the graph, right? It's
Yeah,
not-
it's for the graph. It's the equations of this graph. I already showed you the equation, right? So if I put the folder, now let's look at this. If I put a folder and then I hide it, I can put this inside the folder, and I can see this option? Hide this folder from students. So when you later on display this activity, the student don't see the equation. Right? So I can now suppose I finished, okay? Although I can add more slides, right? I finished this one, okay, I can ask, this is the question one. This is title here. Okay? And then I go on to next. Right? If I finish adding the slide, then I click on next, publish. Okay? Can you see this?
Yes.
I'm press it. So I go back. This is my new test. Now I can create code. Can you come to try it? Can you enter it? Can you also see the code here?
Yes.
Even if I close the window, you can still see the code here, right? I can reopen it again. Can you enter it?
Sorry?
Yes.
If you remember the code, you can enter like infinite number of times.
Oh, yes.
Always.
Right. Yes, you can base on the code, right? Or you can copy the link.
Okay.
Or you can just send the code. It's the same. You can tell the student the code. Right? Now, do you notice that you don't see the equation, right? But I can ask you to enter the equation. Can you enter the equation?
Yes.
So who is this student? Can you enter the equations now? Just find anything. Well, you don't have to give a correct answer. Yes, okay, just this one, all right? Can you see that? Now you can easily see the word, all right? But what I want to show you is that, although this is wrong, you see the graph. You can continue to adjust it so that it matches this graph. You know what I mean? I'm not simply asking you to do the calculation and give me the answer. You can make a guess and then adjust. This is a different way of answering the question, actually. So you see that? Right, so you can check what's wrong and how far this is away, or you can ask the student, okay, this is your graph, how is it different from this one? Right, so you can ask the questions like this. Although I can also change, maybe I can change the color, I'm not so sure. Or you can change the color, or maybe I can change it. Right, so I can say that the green one is yours, right? The red one is the one I want. What should you do to change it? Now, so you can also see different answers. Now, different ones or different students are doing the same question together. Then I can see the progress. Although it may not be so really synchronized, okay, but I think it's still good enough, right? Then you can see what method should work, okay? So at least I know what's going on together. Or I can see the overlay, perhaps. Now, this is also the overlay. So I can roughly see how many can now come to match the graph. Or I can see generally what do you produce. At least most of you can input a quadratic graph. Okay, right? Okay? You won't give me something very strange. Okay? So most of you are still working in this area. You're not very far away. Okay? So you can still see what's going on. Understand? Okay? So is it very simple? So you can already play with it, right? So this is already one question and one task. Okay? Now I can show you my work. Or you can continue to try. Do you see this question? This is extracted from the IP textbook again. Right? At this time, I picked something from the other AA, right? Applications and not, what's it?
Analysis approach.
No, another book called AI, interpretation, application and interpretation. Okay, yeah. Can you see these questions?
Yes.
Find the quadratic function represented by the following graph. So actually, I'm doing the same question, but I'm doing it in interactive platform. Right? Can you see that? I can just enter the equation, hide the equation, and then ask you, okay, what is the equation? Show me. Okay? Or something below. Even this one, find approximate quadratic functions represented by point graph. So maybe I can give a more difficult one and ask you to approximate it as far as you can. All right, then you can see a variety of answers coming from the student, and then I can pick up something that I want to discuss or share with them. All right? So you can see that, so I can pick up something from the textbook and then transfer it to a decimal activity, but the student experience in different ways. Right? And then you can do the things in a different manner. Right? But of course, you can think about the consequence or what you want to achieve. Right? What's the purpose of doing it? Right? If later on, now you know that these tools are is available, and then you go on to think about it. What would be the possibilities? Right? What would be the type of experience the students can have in working on it? Right? Is it different from the paper and pencil? You can ask some questions like this. Okay, so any questions about this one? Now, so I have shown you how I can create quickly a task, right? And then I can edit it. I think I can have this edit activities. Then I go back to the screen again, and then I can continue to add more questions. So maybe next time, now I want to try another one. Okay, so maybe I want to try something very tricky. I think no one will be able to guess it. Am I all right? Okay, then I can do the same. That's why I said, okay, find an approximate equation for this graph. Okay, and perhaps you can't find exactly this, but it can be interesting to try it out. So this can be another question, and then I can go on. I can go on to edit. You understand? Right? And then add more questions, something like that. And then when you finish, then you just click on next. And then you can see some description. These are optional. Right? You can try to put down more details or more information you like. If it's not ready, yes, you can make it private. Right? So these are the screen, the details, and then publish or save as a draft. Now I have a second version. Understand? And then the previous class cannot access this new version. So if you enter through this code, you can only see the old version. But I can create a new code based on the new version. So you can see one line here to tell you the dash box below are for earlier versions. Right? And starting from this one, you have a new version. Okay? So you can make the adjustment like that. Or you can simply copy this one and then create another version. That means an additional version. Right? So you can have different choices. Okay?
So, sorry.
Yes?
If the student joins a new class, the work they have done before will not be carried.
Will not be carried. Okay. Yeah. It is separate. Okay? Or even if the student actually, without entering using an account, for example, Google account, then even if they log out and then enter again, they are treated as another student, even they use the same name.
Okay.
Right? So they will not recognize Understand? Even if you use the same name, but if you log out and then you go on and then use the same name, then you are still treated as another student. Right? Unless you use some student account. Right? For example, Google account to enter, or maybe register there as a student or as a user, not necessarily student. If you register as a user and then you use your own user account to enter, then you will join the same. You join the work at the same with the same identity. Okay. Any other question?
Sorry?
Yes.
Can we add the deadline to the student?
I don't think we can do it directly, but you can close it, right? And when you can tell a student when you will close the activity, or when you can remember the pacing, right? Maybe at a certain time you can turn it to the first page. Okay, do you know what I mean?
Yeah.
Right? When you think that it's done, and then you can just confine to the first page. In case the first page is just introductory page, for example, right? And or the page will tell you that this activity is now terminated. You can put notice there, right? And it will be open later, something like that. You can give an instruction. Okay? I think you can do it in a customized way. Any other question? Let me see. You can see, yes, but these are for other organizations. So you can see this option. Later on, if you want more activity, you can put it into some collection. So you can see you can edit, share activity, or copy and edit. Right? And you copy and edit. You're copying and edit within your account. Okay? So you can make another one based on the new one, but you can also keep your own one. Right? And for the teacher's guide, I think this is it's not made by me, is it? No. I think you can see the summary, perhaps. It's generated from my activity. But I don't know how to use it anyway. Forget about it. Right. Now, this activity, I think most of the activity are suitable for tablets and laptop, but not mobile. I don't know which one will be good for mobile. I don't see any example. Although you can still use mobile openly, but I don't think it is easy for you to answer or manipulate. But tablet is fine. So some students now may use iPad inside the classroom. For instance, in Hong Kong, maybe they have this tablet device in the classroom, and it can be quite easily done within the classroom. Okay? Not necessarily laptop. It's not necessary to use laptop. Okay. All right. So maybe we take a little break, and then we can try some other activity and let you know what else you can do. Because it's only a very simple kind of question that I just created using the graph, right? We can try some other things later on. So let's take a little break, right?